Hello everyone, a very warm welcome to your today's session. Today I Priyanka Mukherjee, a trainee teacher of Kalna College, is here to present before you. So today we will know about the basic concept of the structure of atom from class 9. So let's get started. So student, tell me, we all know that atom and molecules, so the atom and molecules are the fundamental building block of matter. So what is matter? Do you know that? Matter is something that is occupy some space and has some mass. Now, if you think about what led to the discovery of subatomic particles, what happened? That people realized that atom is divisible. So all you remember Dalton's atomic theory? Dalton told us that atom is indivisible. He said that atom can't be divided further. But then after some time, after some years, people started observing the presence of static charge in different things. When you are combing your dry hair, all of a sudden you might feel some charges is being developed there. When you are just rubbing a woolen cloth rapidly, then you can see there is some presence of charge, that is also known as static charge, that is developed here. And also lightning is happening. So that all these example from our daily life led to the people had idea that no, if atom is neutral, then how is the charge is getting developed, how the attraction and repulsion between certain things is happening. So people started observing that if atom is neutral as a whole, but inside atom there is definitely presence of some charged particle. And then Sir Thomson started discovering it. When he recognized it, okay, so atom might be there is present of some charge. So he studied the negatively charged particle inside an atom, and that is something we call as electron. And the next is proton. Now when I say proton, so we all know that if atom has a negatively charged, and also on the other side an atom as a whole is electrically neutral, so there would be some positive charge that is keeping it neutral. So this positive charge first studied by the Sir Goldstein in 1970, and finally quite late in 1932 neutrons were discovered by Sir James Chadwick. Okay, so the next slide we will know about the mass of an atom. Mass of an atom is equal to the mass of the proton sum of the mass of the neutron. So we can say, so the mass of the proton plus the mass of the neutron in the nucleus, present in the nucleus. So now talking about the next point. Since the subatomic particles were discovered like electrons, protons and neutrons, now it was the time that we talk about the structure of atom. So let me tell you about the Thomson atomic model. In 1897, the English scientist J.J. Thomson provided the first hint that an atom is made up of even small particles, and he proposed a model of an atom that is known as palm pudding model or watermelon model. In this model, he said that atom were made from a positively charged pair with negatively charged electrons are embedded in it, like resins in pudding, and those negative and positive charge are equal in magnitude. So the atom as a whole is electrically stable. When Thomson model of an atom was given, the neutrons were not yet discovered. So which subatomic particles is missing in the Thomson model? That is neutron. So now Now we'll see Thomson model of an atom. In this model, Thomson said that, have you ever a half-cut watermelon? This watermelon is spherical in shape. But how is it related to atom? Atom is also spherical in shape. He said that. So in the watermelon, we have this red part, red edible part, that is positively charged, and the black seeds, that is the negative electron. In an atom also the whole surface is positively charged. Whole surface is covered with protons. And have you ever seen the seeds in the watermelon? They are like the negatively charged electron in an atom. So atom is spherical, and on that spherical surface is covered with positive charge. On that positive charge, negatively charged electron are embedded like the seeds of the watermelon, and the total positive charge will be equal to the total negative charge. This is what Sir Thomson state. He also called it watermelon model and a palm pudding model. He compared it in the same way because he said that only the positive and negative charge equal. So that means the model explain the neutrality of the atom. Atom as a whole is electrically neutral. Okay, now what were the limitations? That it was a theoretical model. There were no experimental proof, and all the other experiments that were conducted by Rutherford, any of the other observation was not aligned with this model. So the result of experiment carried out by the scientists couldn't explain by this model. Now if we talk about the next model that was given by the Rutherford, who was the student of Thomson. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. So Rutherford designed an experiment for this. This is also known as Rutherford's alpha ray scattering experiment. In this experiment, Rutherford used a radioactive source. Okay, wait a minute. Radioactive source that is kept in a lead block, that is a glass container. From this radioactive source, alpha particles emitted. One alpha particle is equal to the helium nucleus. There is 2 proton and 2 neutron. Alpha particle are doubly charged helium ion since they have a mass of 4 unit and the charge is 2 unit. Now in front of the radioactive source, he has taken a very thin gold foil. Why only gold? Because gold is the most malleable, so the thinnest sheet is possible when you take gold metal as foil. And alpha rays were made to fall on the gold foil, and around this he has also taken a screen. Look at the image here. A screen is used, that is zinc sulfur screen. So again, whenever a charged particle will came here, it will start glowing. So when the alpha particle were made the fall on the gold foil, then there were certain observations. Alpha particle in this experiment, it was expected that alpha particle would be deflated by the subatomic particles in the gold atom, since the alpha particles were much heavier than the protons. Rutherford not expected to see large deflection, but the alpha particle scattering experiment have totally unexpected result. Now we will see the following observation were made for the scattering experiment. So the observation number 1 is that most of the fast moving alpha particle pass straight through the gold foil. Most of the fast moving alpha particles straight through the gold foil. Now the next observation Observation number 2, that some of the alpha particles were deflected by the foil by small angles. Make a small angles. So some of the alpha particles were deflected by the foil by small angles. And the next, the last and the third observation is the surprisingly one out of every 12,000 particle appear to rebound 180 degree. A very small fraction. Surprisingly, 1 out of every 12,000 particle appear to rebound. A very small fraction of alpha particle were deflected by 180 degree, indicating that all the positively charged mass of the gold atom were concentrated in a very small volume within the atom. So, what are the conclusion of this experiment? Conclusion number 1, that there is a positively charged center in an atom called the nucleus. Near all the mass of atom resides in the nucleus. Most of the space in an atom is empty because most of the alpha particle pass through the gold foil without getting deflected. And conclusion number 2, very few particles were deflected from their path. The positive charge in an atom is concentrated in a very small volume because very few particles were deflected from their path. That indicating the positive charge on the atom occupying very little space. And the third conclusion, a very small fraction of alpha particle were deflected by 180 degree, because indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. Next, Rutherford nuclear model of an atom have some features. So the features number 1, the electron revolves around the nucleus in a circular path. Number 2, the electron, the positively charged centered in an atom called the nucleus, and the electron revolves around the nucleus in a circular path. The size of the nucleus is very small as compared to the size of the atom. Then there was a drawback, that is also known as the Rutherford nuclear model of an atom. So the drawback of Rutherford model of the atom, that the revolution of the electron in a circular orbit is not expected to be stable. Any particle in the circular orbit would undergo acceleration. Nucleus is the positive and electron is the negative charge. So during acceleration, charged particle would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. Radiate energy, and that's the reason the electron lost energy and finally fall into the nucleus. And if these were so, the atoms should be very unstable, highly unstable, and hence matter would not exist in the form that we know. We know that atoms are quite stable. So that is the drawback of Rutherford's model of the atom. So he was not able to justify the stability of an atom, and this led to the failure of Rutherford's atomic model. So we didn't explain the stability, that was the most important thing. Then Then comes Bohr model of atom. Niels Bohr come into the picture, and in 1915 he discovered the nuclear model of atom. In 1915, Niels Bohr. This Bohr's model was based on the Rutherford's model, and due to the drawback of Rutherford model, Bohr modified this model and explained and said that this model is known as nuclear model of an atom. In this model, he said that electrons revolve around the nucleus in a fixed orbit. Electrons move in a fixed orbit. each electrons move in a fixed orbit, and every orbit has fixed energy level, and in every orbit has fixed energy level. He said that those electrons are far from the nucleus, mean maximum distance between electrons and nucleus, those electrons has more energy, that is E3, and those are close to the nucleus that has less energy. Now, so E3, E2 and E1. Now move to the postulate of Bohr's atomic model. So the first postulate 1, in an atom, electrons revolving around the positively charged nucleus in a definite circular path called orbit. Orbit 1, orbit 2 and orbit 3. And each orbit has fixed energy level E3, E2 and E1. Next, the postulate number 2. The energy levels are represented by an integer known as the quantum number. So, n stands for quantum number, that is 1, 2, 3, 4 and goes on. So, now the third postulate is the electron in an atom move from lower energy level to the higher energy level by gaining the energy, level. And postulate number 3, second part, that an electron moves from higher energy to lower energy levels by losing energy. These orbits are also known as cell. Here we can call them energy levels, and they also were represented like the first energy level will be K cell, and the second is L cell, M cell is the third one, and N is the fourth one, and so on. Now the next is the electronic configuration. So still now we know that how electrons are revolving around the nucleus in an atom, but are we aware how electrons are present inside that? So electronic configuration are the arrangement of electrons in energy levels around an atomic nucleus. Now the next point is rules for the writing electronic configuration. So the first one is the maximum number of electrons present in a cell is given by the formula, that is n to n square, where n is the orbit number and or energy level index, that is n is equal to 1, 2 or 3, and the maximum number of electrons that can be accommodated in outermost orbit, that is 8. And the last one, the third one is electrons are accommodated in a given cell unless the inner cell are filled, that is the cell are filled in a stepwise manner. Now in this slide for electronic configuration, let's take the example of argon. Argon is having an atomic number of 18 proton and 18 electron, because we all know that number of proton is equal to the number of electron. So I have to fill in the 18 electron in the cells. So now first I will start filling the K cell, that maximum capacity 2. Then I will go to the L, maximum capacity 8. Then I will go to the M, that is also 8. So 288 is the configuration of argon. Now the next point is, what is valency? Valency is the combining capacity, mean the number of electrons gained or lost or shared gives us directly the combining capacity of the element, that is the valency. Now atomic number. Atomic number is denoted by Z, and this is the number of proton of an atom. And next slide is mass number. We already known about that the mass number is the number of proton and the number of neutron present in the nucleus. For example, the mass of carbon is 12U because it has 6 protons and also 6 neutrons. So 6 protons plus 6 neutrons is equal to 12. So here is a symbol. We can see that here A is the mass number, and the red smiley is the proton and the green smiley is the neutron. Now, what are the notation for representation of element? That is this, and for this here X is the chemical symbol for the element, and A is the mass number, that is A is equal to Z plus N, where Z is the proton number and N is the neutron number, and And the below, the Z is also known as atomic number of proton. Now move to the next slide, that is isotope. Isotope are atoms of the same element have different mass number but same atomic number. For example, take the case of hydrogen atom. Hydrogen, deuterium and tritium. Here the number of proton is 111 but the neutron number is 0, 1 and 2. So that is the example of isotope. And the next point is isobar. Here is the vice versa of isotope. Mean the same mass number but different atomic number. So let us consider three elements: argon atomic number 18, krypton atomic number 19 and calcium atomic number 20. So here we all see that in these three atoms have 40 mass number but have each element has different atomic number. So that is isobars. So for today I would like to end this presentation. Thank you so much everyone.